everyone, and my presentation is on the topic optimized algorithm for VM load balancing in cloud computing. What is cloud computing? IT resources and services that are extracted from underlying infrastructure and provided on demand and at scale in multi-tenant environment. What is load balancing? It is a process in which there is reassigning of load to individual nodes of a system is done by avoiding underloaded and overloaded conditions. The important thing which are to be considered while developing such algorithm are selecting of nodes, nature of work to be transferred, interaction between the node, performance of system, stability of different system, comparison of load, estimation of load, etc. What is the objective and problem statement? The objective is to reduce the average response time and average data center processing time with the help of proposed VM load balancing algorithm. In our proposed algorithm, we have distributed load on those VMs which are underloaded. Compare the existing algorithm, compare the existing load balancing algorithm with proposed Honeybee load balancing and Ant Colony load balancing algorithm in cloud analytics. Proposed algorithms are Honeybee load balancing algorithm and Ant Colony load balancing algorithm. Honeybee load balancing algorithm. In this process, we have considered Honeybee as our inspiration, in which we have considered input as VM state which is available or busy, VM allocation and fitness. The output produced is underloaded VM which contains least number of cloudlet. The steps which are required in Honeybee load balancing algorithm is calculate the fitness of all the virtual machines. For each VM we have to perform waggle dance to find which are underloaded VMs and which are less loaded and which are overloaded VMs. Then we select which is the most underloaded VM based on the waggle dance and the fitness, and then allocate the cloudlet to the selected underloaded Ant Colony load balancing algorithm. The input which we are considering are VM count, ferromene, probability. The output produced is underloaded VM. First of all, what we do is initialize the ferromenes, then move the ant through VMs to lay ferromene trails. We calculate the probability according to the VM visited. Upon updation, then we perform updation of ferromenes. Then we select underloaded VM which has the highest probability from probability of all the VMs. Calculate the cloudlet, allocate the cloudlet to the selected underloaded VM. Configuration. We have performed our experiment in Cloud Analyst, and the configuration which we have done is as shown below. In this we have taken 6 user bases in different regions and having different configurations, as you can see here. The metrics which we have considered for evaluation are average response time and average data center process. The results which we get after performing the experiments are as shown below. In this experiment, we have considered 5 scenarios and we have calculated the average response time and average data center processing time with correspondence to the provided round robin and equally spread current execution algorithms with Honeybee and Ant Colony. Similarly, the data center processing time is given here. Results analysis. The proposed algorithm shows significant reduction in average response time and average data center processing time. The reason for improvement of average data center processing time and average response time for Honeybee load balancing algorithm is it does not cause overload or underload problem as it happens in round robin and equal spread current execution algorithm. Honeybee load balancing algorithm always send cloudlet to those VMs which are underloaded. The reason for improvement of average data center processing time and average response time for Ant Colony load balancing algorithm is similar to round robin and equally spread current execution algorithm. It does not cause overload and underload condition. It always sends cloudlet to a VM which is underloaded. Ant Colony load balancing maintains queue for each VM and send cloudlet to these VM which has less number of cloudlet probabilistically. In this work, we have optimized VM load balancing techniques that are Honeybee and ant colony load balancing. The results gathered by both the algorithms were then compared with the existing algorithm. Both the algorithms show reduction in average response time and average data center processing time. In future, we can also develop other optimization algorithms and we can perform a comparative analysis of which performs much better than the given algorithm.